are live, I think. There we go. Let's make sure that we're live because it's always good to be live. I always check everything. How's everyone doing this evening? We're good. All right, good. We're live on YouTube. We're live on X. We're live on the chat. Everything's live. Okay. So, we've had a lot of interesting things evolve over the past couple of days. We were going to talk a great deal about whether or not we'd have opening day tomorrow, but that's already been taken care of because Major League Baseball came to their senses and said, hey, we're just going to wait till Friday, which is very smart because there's just going to be sunshine. We don't have to worry about rain, how heavy the rain, or anything of that nature. So that's certainly some good news. The Weather Channel, I'm sorry, not the Weather Channel, one of the other providers, I would put it that way, I think it was AccuWeather, basically put out a idea on the tropical forecast. And, of course, as always, extreme. I feel like I'm watching a 90s commercial sometimes. You know, like back in the 90s where every toy was extreme and they played the guitar and all that good stuff to be the most extreme trading card, most extreme drink. Well, now we have the most extreme hurricane forecast. Look, we'll talk about it tonight. Obviously, very warm Atlantic. We're shifting towards La Nina. Will we have an above average hurricane season? Most likely. Okay. But a couple of things to consider. We don't have the data yet, and this is why you have to consider it. Things like dry air off the Sahara Desert. Okay. Now, a couple of years ago, the idea was well above normal hurricane season. We got there eventually. But the key of that season was that the first half of that season was nearly very quiet and left a lot of people wondering what happened to this forecast because of all the dry air coming off the African coast. My point is that it is good to warn people like, hey, look, this looks like an above normal season. It's not good to scare people. Okay, that's not what we want to do. We want to educate people, get people prepared. Not scare them so they watch your channel or watch your website more. So, yes, it does look like it will be an above average season, especially with all that warm water out there. Doesn't mean that we know where they're going to hit. There's some debate on that in terms of where the prevailing storm tracks are going to be. There's a lot of debate in terms of how much wind shear is going to be focused in the Gulf of Mexico compared to the Atlantic, where we'll be with that La Nina by that time. But we don't want to jump to conclusions. And we certainly don't want to use extreme, there we go, language to produce a forecast. Let's educate, not scare. Educate in terms of, hey, it looks like an above normal hurricane season. Do you have your supplies ready? What do you need to check? This is a checklist of what you should do. Like you check your flashlights, check your batteries. Do you have food that you can, canned food, water, stuff like that. Be prepared. Not, oh my God, the world's going to end. Because that helps nobody. Absolutely nobody. So, just my little 2 cents on that. Also, just to let you guys know, I am working on a series about the Certified Digital Meteorologist seal from the AMS. I'm going to create videos on not only how to get it, but how to prepare. Like, for example, how to get ready if you're taking a test at home. Trust me, you're going to need this video because the test you have to take, it's hard. First of all, especially if you've been out of college for like 20 years like I've been and you're not used to taking those tests, I'm going to explain best ways to get prepared for it and also how to prepare your testing area because it's something I didn't know that drove me insane. So I'm definitely going to be going over that and sharing some good resources to study for and how to basically set up if you have a private business yourself, or you want to learn how to be a consulting meteorologist, a digital meteorologist, how to set that up. So we're going to be working on a whole series. I'm working on the draft right now. It'll probably take a couple weeks, and then we'll shoot our first video, and we'll have it in a special section right on YouTube, and of course at nynjpaweather.com. Now, with all that out of the way, go Mets. No, just kidding. Let's talk about La Nina, or what's developing as La Nina. Now, right now, for the first time in months, we have a negative anomaly. Granted, it's only minus 0.1 degrees Celsius, but it is starting to make that change. We've been watching this change gradually for quite some time. We know that the forcing in the atmosphere is starting to change. We'll talk about that in a moment. You can see the average sea surface temperature anomalies are starting to shift here, becoming cooler and cooler. And when we look at the last 4 weeks, you can see that evolution starting to take shape. Signs of that La Nina starting to show up, with your warm anomalies all focused over the western regions. And if we take a look at the change in weekly sea surface temperature anomalies, you can see clearly everyone is gradually cooling. So we're certainly moving in the right direction in this respect. And that means we'll start to see more and more changes in the atmosphere. One of the things that really stands out to me in terms of sea surface temperatures, and this is something that you can use, again, this is completely free data. There isn't anything something like unique or you have to pay for. Well, you already pay for it. It's your taxes, right? cpc.nsep.noaa.gov, you'll be able to find all this data. Now, you see this cooling right here? See that showing up right there? That feature right there tells us, gives us a signal that ENSO is starting to change. So when you see a spike going warm, that means El Nino is coming, and then it gets sustained. When you see it dropping negative like this, that means La Nina is coming, okay? So it's a good headwind. If you're not sure whether or not an ENSO change is going to happen, you take a look at this chart, and what this does is that it gives you the heat anomalies for the upper ocean. So not just the surface, but just below the surface as well. And you can see that showing up really nicely when you get this analysis here, this cross section. Look at how the sea surface temperatures and the subsurface temperatures have changed over the past couple of weeks. So clearly you're starting to see this evolution, and clearly you're starting to see support for, at the very least, the development of a moderate La Nina, possibly a strong La Nina, depending on just how deep, not just how strong, but how deep these negative sea surface temperatures, these cold sea surface temperatures are. So when I'm forecasting for ENSO in the long range, okay, in the seasonal range, what I want to do is first study the sea surface temperature anomalies below the surface, because that tells me what's coming, right? What's in the stock range, right? What's coming up that is going to feed the surface. And as you can see here, we have a great deal of cold water building here. Not a lot of warm water over the eastern section, especially deep in the subsurface. All your warmest waters are down here. Why is this important? Well, what I want to start trying to do is figure out where is the thermal gradient when we study the greater ocean, the Pacific Ocean. Where is that gradient between the below normal temperatures and the above normal temperatures? Because that's going to give me a signal of where the convection is going to be in the Pacific. So when I'm looking at this data, and then I study the SOI here is neutral positive. Why is this important? Well, we talked about this during El Nino, right? This gives me the idea of the forcing mechanisms in the atmosphere. So we've been negative in February. Now we trended towards neutral, and now we wait for a strongly positive setup in the forcing mechanism. Right now, very weak. So then the next thing we should look at is the MJO. During this time period with the MJO, it has the potential of being more influential. Unfortunately for forecasters, the MJO is not really all that impressive. You can look at all the model guidance, and basically what it's suggesting is either a very weak phase 1, 2, 3, and then going into 4, or going into a neutral state and eventually trying to get into 4. So when I'm looking at all this model guidance and seeing the different solutions that it's trying to pull up here, the overall theme, weak MJO signal, very progressive. So there's nothing locking in to allow me to sustain blocking. And now that we're moving towards spring, which is, of course, one of the warm seasons, that driving mechanism starts to get a little muted. So you have to start studying the pattern and seeing how the convection is starting to develop in this new environment. So when we take a look at the convection that's firing up here, we're seeing a focus at and to the west of the date line. Meanwhile, the polar jet stream with a Pacific influence clearly is extremely active. It's just a train of storms marching across the Pacific, heading towards the Pacific Northwest and diving into the plains. So what does this tell me when I just look at this? We're not even looking at model guidance yet. When I'm looking at this and looking at the changes going on with tropical forcing, at this point, we're not really concerned about the stratospheric influences because that's fading rapidly. Every day that we gain more sun angle, the influence of the stratosphere is becoming less and less of a factor, to the point now that the polar vortex is very, very weak and the winds have reversed back to where they should be. And in fact, we're moving towards an above normal state. So it's a limited influence. So the dominant driving mechanism is the very wishy-washy tropical influences in the atmosphere with a changing dynamic in ENSO. So when you have that situation, you need to study the satellite picture to get a better idea of where is our convection developing and how is that developing. And the overall theme is that you get this active storm track marching into the West Coast, which means that the United States is pretty much going to get flooded with Pacific air masses going through the middle of April. While the subtropical jet stream is active, it still has kind of that echo from the El Nino influence, but it's clearly dying down. It's nowhere near as active as we were seeing a couple of weeks ago. So the dominant theme is Pacific air masses with some influence from the Gulf of Mexico. You'll get an occasional polar shot here and there, but maybe they'll last 24, 36 hours at most. This is a wet, active pattern for us. Now, why do we see all this convection here? Well, let's take a look at the sea surface temperatures. This aspect here is partially an interesting driving mechanism with climate change in a way, because we're seeing such warm sea surface temperatures. And there is studies that are going on right now, and I'm looking forward, hopefully they'll be done by the time we get to fall, so because they'll help with seasonal forecasting, on the changes that we've seen in the Pacific in terms of the different anomalies that are setting up and the gradients that are being driven, and how that might be influencing the tropical forecasting, the tropical forcing forecast, i.e. El Nino, La Nina, MJO factors, so on and so forth. Combine that with our changes with the water vapor in the stratosphere and how that is working. There's two separate studies going on. So hopefully, once we get that data to come out, we can study them and start to combine that to get a better idea on seasonal forecasting. But for right now, let's just take a look at the storm track. You have an active Pacific storm track. Well, that happens to be occurring right over where we have our strongest gradients. Now, we don't see much of a gradient here around the tropics. Okay, now normally when you have an El Nino, right, you get some below normal sea surface temperatures here to set up your gradient. We don't even have that. Why? Because we're in a state of change. These warm sea surface temperature anomalies are likely going to linger as our La Nina develops. Notice the cold areas here. So right now, the tropics and the ENSO region is kind of muted, right? Because we don't have that gradient. Where we do have that gradient is up here. So these storms coming off of Asia are becoming enhanced by this gradient combined with air masses that are coming off of the Asian coast. These storms are getting amplified as they're marching their way through, which also enhances different areas of cold water and warm water because of that process of mixing, and then slamming into the United States. And this leads to a very active stormy weather pattern. And that's why we're seeing what we're seeing here in our 500 millibar pattern. Very active pattern, very progressive pattern. Yes, I see that there is a strong high pressure system around Greenland, but notice the overall theme here is that the polar jet stream under this influence is being displaced to the north. So, and this is typical of spring. So what this typically means for us is not polar air masses. I know a lot of people are running around saying, oh, second winter. Still, no. What it is the influence of maritime air masses. From where? Basically the Canadian Maritimes. So this is a signal for raw weather. So when I'm seeing this, I see a storm track cutting into the Great Lakes, warm front trying to drive through the mid-Atlantic. You see how you have this gradient right here? This would probably set up a high pressure system right around here and a backdoor cold front. So in these type of scenarios, what we have to watch out for are backdoor cold fronts and significant rainfall events. You could also see that very nicely here on the GFS and on the European ensembles. So the overall theme is progressive, active, and the type of air mass clashes will be Pacific, Canadian Maritime, and tropical from the Gulf of Mexico. That's the overall theme. And a lot of that is driven by the active Pacific pattern that is going to be hitting, and it has started to hit, the United States. And so when you have that type of scenario, if you're not sure whether you're dealing with pure polar air, like if you're just looking at 500 millibars, or you come across someone that just posts a 500 millibar map and that's it, and says, hey, look at this block, take a look at your temperature anomalies. Okay, we're going to march on through. Now, what's the overall theme that we see? And again, you don't want to take this verbatim, okay? We're not taking this verbatim, but look at the overall theme. Here, I'll hit play, okay, and have you watch it while I'm talking. The overall theme is that this is very progressive. The air masses, both warm and cold, are transient. This is textbook of a progressive Pacific pattern. Cold air can't stick, warm air gets kicked out. Very, very active weather pattern as a result. And when you set up this type of active weather pattern, you end up with this type of precipitation anomalies. Now, why do we have this type of precipitation anomaly on the East Coast? Well, let's think about this here. You have Pacific storms marching across the United States. So they're not really picking up much moisture till they get to the Gulf of Mexico. Then you see this moisture plume right here. What's happening? Well, you have a trough marching in. You have some interaction with the subtropical jet stream. So there's your moisture transport, much like what we're starting to deal with over the next 24 hours. And then you see this uptick here in anomalies, an uptick here. Why is this happening? Because the model guys is trying to figure out where the clash between the Pacific, the tropical, and the maritime air masses will set up. This is a signal for a stationary front as an overall theme. So this is a pattern that has the potential for above normal precipitation. Yes, urban flooding, small stream flooding. If you're already seeing ponding in your yard, guess what? It's going to continue. And I don't really see this pattern changing all that much. Maybe late April, maybe. So this also means if you have baseball tickets, you might want to make sure you understand that rain delay policy. You're probably going to need it. Yankees, Mets, Phillies, down to Baltimore. Definitely be prepared to have an idea on that. So that's the overall theme of the pattern. Now, as far as our storm that's evolving, we could already start to see showers starting to break out throughout the region. And you can see on the radar here on WeatherTap, which I've used since 1998. They don't pay for that as far as like me saying that. What is it called? Sponsorship there, but I just love their product since 1998. And it's always been good to me. So I like using it. So what do we have here? Well, it's pretty much what I just described, right? We have a maritime air mass getting driven out. We have tropical moisture driving up the coast with waves of showers. We have this area right here that we're going to be watching for heavier rainfall. Now, for the past couple of days, I've been talking about the lifting being displaced to the east, and that is exactly what's going to happen. That's why the whole region is going to get 2 to 2.5 inches of rain. The reason why, well, let's take a look at the satellite picture. First, the infrared satellite picture. I love using this because it gets a good idea on the lifting, right? So what do we learn from the lifting? Well, the cold cloud tops here. The colder the cloud tops, the stronger the lifting. The stronger the lifting, the colder the cloud top, because the cloud top is higher up in the atmosphere. Perfect example is down here in the Gulf of Mexico. We have a nice thunderstorm firing off. Boy, oh boy, is it impressive. And it is marching to the east pretty quickly. Notice the theme here. Everything's sliding to the east. Why? Well, let's take a look at the water vapor satellite picture. Well, look what we have here. Deep trough from the Pacific, from the polar jet stream, getting kicked east. Why is it getting kicked east? Because you have a trough coming into the west coast. So everything's progressing to the east. As a result, your strongest lifting and your best moisture transport, which we could see right here, and also in this data here. This is all getting pushed off the coast. So yes, we're going to see periods of rain tonight through tomorrow. The difference is that we're not seeing the heaviest rain. So we'll probably pick up anywhere between a quarter to an inch and a quarter of rain over much of the region. If you're looking for the heaviest rainfall, based on what I'm seeing here with the lifting dynamics and what I'm seeing here on the water vapor satellite picture, Atlantic City, Cape May, the extreme coast of New Jersey, east end of Long Island, I wouldn't be surprised if someone gets around 2 inches there, and then like southeast of New England, okay, eastern New England, this area right here, okay, so those areas, that's where we're going to get into that plume of very heavy rainfall, where you're definitely going to be pushing over 1.5 inches of rain. But further to the west, we're going to have a tighter gradient. And that gradient is because everything's getting kicked east. And so we're seeing that very nicely here showing up. Okay, notice in the guidance, you get this focus here of moderate rainfall. Here's your heavy plume down here at 18Z, which is now 2 p.m. because they screwed up the clocks. Now it clips southern New Jersey, the Jersey Shore, and heads towards Long Island. And then at 0Z, it gets pushed further off the coast, and we just get light to moderate rainfall. So there was never a doubt whether or not we'd see rain. That was never my question. The question was whether or not we'd get the heaviest rain or get more of a light to moderate rain. And so the forecast that has been adjusted that we've been working on, and you know what? Here, let me show you. So I'm talking about it. I might as well just show you it. Let's see here. Impact. There we go. Okay, so this is what I've been showing premium members. And as a premium member, in case you're not a premium member, you can go into the dashboard. You can zoom in right down to your town. Heck, right down to your house. So that way, when we do get to the winter and you want to know how much snow in your backyard, you can literally zoom into your backyard and don't have to email me. So it works for everybody. In this scenario, looking at 1.25 to 2.25 right along the coast, you can see right along the Jersey Shore, up to about Tom's River, and then towards the east end of Long Island. 1/4 inch to 1.25 inches. Why the range? Well, most of this rainfall is going to be light, and then you're going to get some bursts of heavier rainfall. And in those bursts, that's when we start to go over 1 inch. There's going to be a very tight gradient here based on that burst, and out towards eastern Pennsylvania, 1/10 to 1/4 inch. Not really that big of a deal. One last thing I want to touch on, and then I'll answer all of the questions here. I noticed that some individuals were posting the NAM and this specific solution. Yes, snow. And of course, snow maps. I don't know why, but okay. Why would it be a bad idea to post this map? Well, you take a look at this and then you take a look at the snow maps. Remember, model snow maps are nothing more than QPF, the precipitation, times whatever the 850 millibar temperature is. So at 0 degrees Celsius and 2 inches of QPF, it drops 20 inches of snow, regardless of what's going on at the surface. That's how a lot of these snow maps work. Not all of them, but a lot of them. So when you take a look at the thermodynamics at the surface in this scenario, let's do shade here. Hey, look, it's in the mid to upper 30s in the middle of the day in March. Why is this an issue? Well, let's just say this is at the evening. I'm sorry, this is in the evening hours, okay? Why is this an issue? Well, okay, couple problems. One, the precipitation is leaving. Okay. 2, cold air is very marginal. 3, and this is the most important thing, boundary layers are very warm. So even if you saw a wet snowflake, it wouldn't accumulate, regardless of what snow map. But more importantly, let's go back to the radar signature here. When you have this scenario, what you want to do is take a look at what the mesoscale guys, what the higher resolution is showing at 3 kilometer. Why? Because this whole thing that's being shown here is dependent on dry air not cutting it off. Look at that. No precipitation. Why? Because this resolution has a better idea on the moisture transport and how fast the precipitation is going to get cut off. And as a result, it removes that solution. And also, if you want to take a look at the sounding, what you have up to about 925 millibars is above freezing conditions, which even in the evening hours, late at night, midnight in March, is very difficult to pull off any type of accumulation. You want to, at the very least, around 34, 35 degrees. Notice also, if we can zoom in on here, the increase of dry air. What is this telling us? This is telling us that dry air transport is starting to take hold. So when you study this and you look at everything, that's when you don't advertise these type of solutions. Not to mention it's not showing up in any of the guidance, but this is how you tell whether something's realistic or not. You take a look at the whole realm. You take a look at the greater resolution and then say, okay, does this make sense? Doesn't look like it makes sense to me. So that is it for talking tonight. Now let's answer your questions, because it looks like we have quite a few going here. And YouTube looks busy as well. So let's get to those questions. If one needed any more proof that solar panel farms are not a good way to generate reliable electricity, just look at the huge solar panel farm that was destroyed by hail yesterday. Yeah, I think solar is a great potential for additional electricity. But I'm not convinced it's good for the main source. So I'll give you an example. Around here, New Jersey, we have solar panels all over the houses, right? Great idea. reduces electricity use. You can literally pay for your own electric bill by having the solar panel on there. And for the most part, it doesn't, if the hail hits your house, it doesn't impact the other houses. So, yeah, I mean, definitely. Solar has a place. I just hope that some people don't over rely on it. We shouldn't over rely on any energy. Why don't they just go with the line from Godzilla from Destroyer when X1 pilot tells his crew, there goes our budget for next year? Well, I don't know. Let's see. AccuWeather is clickbait. They need to do a little better. Let's see. Curious to see how strong the subtropical jet stays as La Nina gets established, while it will retain the unusual strength from La Nina like the last one. I think part of that has to do with the state of the sea surface temperature anomalies in the Pacific and the influence of that above normal water vapor in the stratosphere. Now, the influence of that of the stratospheric water vapor is subsiding. Okay, it's not going to disappear for at least another 30 years, but it is starting to subside in terms of concentration and intensity. So I don't know whether, I don't think it's going to have as much of an impact, but the sea surface temperatures certainly have my attention, and I think it might be a factor. Sunspot pattern has gotten very interesting. Southern line of spots is lined up right along the equator, and northern ones in a line above the equator, sign of pending magnetic switch. Yeah, I mean, we're due. I was thinking every Friday for premium members, I do a discussion about solar weather. And I've been thinking the second half of this year, we should start to see that switch and that peak. And it looks like we're heading in that direction. But again, I'm just starting to learn solar forecasting and solar dynamics. There's a lot of great research out there that I would suggest reading. A lot of great stuff in the AMS about it. But I do think we're heading towards a change sometime between the end of this year, right around like the fall, and heading towards 2025. So definitely look out for that. It's going to be interesting to see how that evolves. As much as people are complaining about the wet weather pattern now, I bet July and August, if we get La Nina, hot, dry, heat ridge that is sustained, people will be screaming their lawns are brown. Yeah, I mean, this certainly is great news that we're seeing this rainfall, because we will see a drought. Okay, so certainly good news in that respect. The one thing I'm wondering about with this La Nina, with the way that the orientation's trying to set up, we'll see maybe more of an east-based orientation. That would support more of a Bermuda high. And the last time we had that set up, we had a lot of hot, humid weather conditions and those persistent thunderstorms. And depending on how they line up with the gradients, moisture gradients around the Delaware River Valley, that could lead to some areas leading to flash flooding. Remember that one thunderstorm back in 2 La Ninas ago sat over JFK and Newark and just caused massive flooding. So we definitely have to watch out for that as well. Steve, I find it easy to see the air mass flows from the water vapor. Yeah, absolutely. Water vapor is a wonderful tool, that is for sure. Sun angle at the end of March is the same as the second week of September. Absolutely. Yep. This is why you really don't want to post snow maps. Update on hurricane season. Okay, well, my general thought is this with the hurricane season. I definitely like the idea of above normal. Here, let me go pull up the map. Okay, so let's see if we can zoom in on this here. Okay, so here's the concern that a lot of people are pointing out. Now, we have a La Nina on the way, so that means we have a lot of weak shear over the Atlantic. The sea surface temperatures right now are well above normal. They're pretty much at the level you would expect them to be in June. So that's incredibly surprising. Now, that alone would support the potential that any tropical wave that comes off the African coast is going to be able to sit up and spawn pretty easily. It's going to have plenty of energy to use, plenty of moisture, plenty of heat content to use from the oceans. The other thing that kind of catches my eye is this gradient here. Now you might be saying to yourself, Stephen, that looks chilly. Yes. A lot of lingering upper level lows. Watch out for subtropical low pressure system development around the southeast coast, which could transition over to tropical storms and so on and so forth. That signal definitely has my attention as well. Now, what I don't know, as I was discussing, I don't know how strong of a dust transport we're going to have off the Sahara coast. All right, the Sahara Desert's right here. And the last time we were looking at a well above normal and everyone was freaking out, dust killed half the season. It was very quiet. Once the dust got overwhelmed, then the hurricane season really acted up and really became active. But even with that, that doesn't mean you're going to have a lot of landfalling storms over the United States or around the Caribbean. We don't know those answers, and it's irresponsible to make any type of decision on that. What I will say is that there's going to be plenty of heat content in the ocean to feed upon for these tropical lows, and we're going to have to really keep an eye on that. When you have a La Nina in place, and we get that Bermuda high locked in, if that signal of that negative NAO that we're seeing right now continues to linger into the warm season, that is a concern. But we have a long way to go to lock that in. The other concern that I have is anytime we see any type of trough or upper level low anywhere near the Tennessee River Valley, that is a bad signal for the Mid-Atlantic and New England, because that type of signal allows for transport of tropical low pressure systems from the Bahamas up the East Coast. So that is something that we're going to have to watch out very carefully. But the key thing that we know, and this is pretty much it, is that the Atlantic is chock full of fuel. I mean, this is like nitroglycerin out here. And the Pacific is moving towards La Nina. So high potential for weak shear and plenty of energy to feed on. That is essentially where we're at right now. Whether anything is going to be extreme or strong or anything of that nature, we simply don't know. We don't have the data for it yet. But that's pretty much where we are right now. But yeah, be prepared for now and go from there, Now let's take a look and see what we have for YouTube. Congratulations on your recent certification. Thank you, Dave. Interesting to see that the warm tropical Atlantic signal persisting for quite a while now. Could be interesting if this continues. Yep, it definitely could be. Are we still in a positive AMO state? Yeah, pretty much. I mean, that's as positive as you can possibly get. Let's see. Even though we're ending the season with below normal snowfall, I stopped complaining after we got 10 inches in 4 hours. Yeah, I mean, that's a good reason too. Do you think we'll see wildfire smoke in the Northeast like we did last year? Great question. That wildfire smoke was driven by basically Canada's poor practicing of preventing fires. Okay? Part of that. The other factor was a persistent northwesterly flow. I don't think we see that this year. I think we see a lot more persistent southwesterly flow, in that case we still have to be on guard for fires around the Pine Barrens and around the Appalachians, but usually those don't get out of hand and we don't let a whole forest burn down if possible. So I think we'll be better than last year. I don't think we see the same type of impacts. Any questions on X?
Nope.
All right. Well, there we go. Nice. So let's see. It's 8:40 already. Not bad. Tropical Pacific seems to be a lengthy stretch of remarkably low activity. Yeah, I expect that to continue. So that's going to be pretty quiet. I think we're going to be busy in the Atlantic. We already had one low pressure system. It was very weak, but it clearly showed subtropical characteristics. But it wasn't named or anything because it was just far too weak. This was to the north of the Bahamas about, I think, when I say 3-4 days ago. The reason why this kind of caught my eye is that in an unfavorable environment, we're already starting to see these types of low pressures systems, and you have to kind of go with an above normal forecast because now the National Hurricane Center is naming these systems and counting them as part of the list, right? So beforehand, I can kind of discount them. They'll be numbered, but they weren't part of the list, and so I wasn't worried about an above normal season. Now that this is baked in, it's very difficult to get a below normal season with these subtropical lows being set up. Okay, solar eclipse weather. We are still too far out. I know that some people are using the GFS and the European ensembles for the long range forecast for the clouds. I want to get under 7 days before. So what I'll do is I'll make posts about that, social media posts, and put a section in the public forecast about that on the solar eclipse weather and the cloud cover and whatnot. But right now, the reason why it's really difficult to make that forecast right now is that you're talking about 11, 12 days out the storm tracks and where exactly it will be. The latest guidance, if you put any stock into it, would suggest cloud cover over the Ohio River Valley and the Great Lakes. So not exactly the best news in that respect. But most likely, I think we'll have more coverage on that next Wednesday ahead of the event. We'll have a heck of a lot more reliable data, for one, and we'll be able to detail that. We'll take a look at the cloud cover setup and get a good idea before the event happens. But I don't think it's a good idea to use any of the long-range guidance for cloud cover analysis, because remember, we're not just dealing with the mid-level clouds, which so forecast, but the low-level clouds, which is really poorly forecast this far out. So we have to wait a little bit to really trust that forecast and really nail that down. But thank you for the question, Dan. And one thing I am telling you, I'm kind of looking forward. Well, I'm definitely looking forward to the baseball season. It's going to be interesting. But one thing I'm really happy about to see is the fact that Major League Baseball didn't wait 15 minutes before the game is supposed to start to call the games and to push them to the next day. Now, I know usually Major League Baseball does this for opening day. They're a little bit more aggressive. But I really wish they were more aggressive with this all year round. And there are 3 reasons why. One, it's really rude to have your fans sit out in the rain waiting for a game to be played. That's one. 2, more importantly, safety. You have them sit out in the rain. They have to drive back in heavy rainfall, so hydroplaning, traffic concerns, whatnot. If it's thunderstorms, you're opening up a lightning threat. And if there's any hail, well, even more so. And then number 3, the threat of those accidents and whatnot could impact someone who may not even be going to the game. So I don't see any positive in having fans sit out and wait for a game that's going to get postponed when clearly there's going to be heavy rainfall, clearly there's going to be prolonged severe thunderstorms. Bite the bullet, do a doubleheader. Protect your fans, protect the general public, and keep everyone safe. This isn't just for like a passing thunderstorm that lasts for like 15 minutes. But far too often we see where they sit there and a line's clearly going to be moving slowly. You have all the model data. Protect your fans, protect your players, and get them out of that situation. So I'm glad what they did ahead of opening day. That's certainly great precedent, and I hope that continues, and they keep us a little drier, right? Because God knows I can't afford a hot dog there anymore because it's just too expensive. What are they, like $90 now? It's crazy, The sportsbook partners of MLB don't like the uncertainty either. Oh yeah. I wonder just how long gambling is going to be associated with baseball, with sportsbook, based on what happened with that Japanese player. Supposedly his interpreter stole money. I don't know about you, but I'm very, very mindful of my bank account. I think I'd start noticing if people were missing millions of dollars. If there's one thing, if it's like you're a millionaire and $1,000 is missing, like maybe you bought something and you forgot, or one of your assistants, $1,000, right? Millions? I don't know. That kind of stands out to me. So I don't know. There's something weird about that, but that's just my 2 cents on it. Something doesn't add up to me. Like, hey, all of a sudden, I just noticed I'm missing millions of dollars. I don't know. I kind of would notice it a little bit faster, but that's just me. What can I say? Gambling has always gone on. Absolutely. No, I agree. I mean, you got Pete Rose and whatnot, and you have the potential for you have literally sports teams in Nevada now. And I'm not like, look, if you want to gamble. That's whatever. That's your thing. I'm just curious to see, not so much that there's gambling, but the fact that you have sports teams literally advertising it. Interesting to see how that dynamic plays out. Let's check the radar and see how our storm's evolving. And we'll put that up. And we'll refresh this. All right. So as we move on through tonight, for the rest of the night, you're going to start to see this rainfall here blossom and expand and push into the northern mid-Atlantic. Don't be surprised overnight if you hear some moderate to heavy rainfall. The heaviest rainfall for much of the I-95 corridor is actually happening tonight into tomorrow morning. Then, once that heavy band gets pushed to the east, as we've been discussing, you're going to end up with the showery type, light to moderate rain, drizzle, just a really raw day out there. Not exactly the best day to have any type of outdoor activities, that is for sure. And that's just going to linger until this frontal boundary pushes off the coast by tomorrow evening. By tomorrow evening, don't be surprised you get a beautiful sunrise setting up over eastern Pennsylvania. Sunset, should I say. Setting up over eastern Pennsylvania as the dry air builds in, and you just get this wonderful red sky showing up. So definitely look out for that. It probably reached central New Jersey by the time the cold front reaches Long Island. I think it'll pretty much be dark by then, but I think that has the potential for eastern Pennsylvania and the Delaware River Valley to have a beautiful sunset setting up for tomorrow with the dry air building in. And with that, since we don't have any more questions, I think we'll call it a night. Thank you again for the wonderful questions. I hope I was able to answer everything that you were wondering, and we'll go from there. So I hope everyone has a wonderful and happy Easter, and as always, stay safe out there.